Okay, welcome back to Nature and Code. We're in chapter 3 and we're looking at random numbers and the issue of coin tossing. So I want to go back to our code here that we just developed. This is fairly straightforward code. Um, we have two variables here that we set up. We then have a loop and we iterate over the value here. uh, uh, well, not over the value, that's the wrong way to say it. We iterate as many times as is defined in this value here. And what we do here is we call math random and we increase this sum variable in order to keep track of the sum of all the math randoms, all the values that are returned from math random. And then we take the average at the end by dividing the sum by repeat, which is the number of iterations we had here. And that gives us the average, and we saw that this is 0.5 on average, or very close to 0.5 as expected. Now, let's implement the coin tossing here. So I would like to develop a method or a function that throws 10 coins and keeps track of how many heads and how many tails we get. Let me first implement the code without actually having this in a function. The important thing to understand is that math random isn't exactly a coin tosser, right? It doesn't just give us heads or tails. It gives us a floating point number between 0 and 1. But we can, with a little trick, adapt this by saying, well, you know what? Whenever this math random returns a value that is smaller than, excuse me, smaller than 0.5, then we consider this a head. And in the other case, we consider it a tail. And so now that's a fair coin that we have implemented here. So let's go ahead and do this. So first of all, I'm going to say I want to have 10 coins that I'm going to throw, or 10 flips. So I want to keep track of both heads and tails. So I'm going to have two variables here that I initialize at 0. One I call heads, one I'm going to call tails. And now I want to have a loop, a for loop, as always. So this is pretty straightforward by now. I is smaller than coins. And let's not forget to increase I by 1 in order to avoid an infinite loop. All right, and so now I would like to throw a random number. I would like to get a random number. But of course, I want to implement this flipping of a coin idea. So like I said, I would like to sort of figure out, did this value now, is this value that I get from math random, is it smaller than 0.5, smaller or equal, or not? And for that, we need a new construct in JavaScript that we haven't talked about yet. And it's a very important construct, and it's called the if, or the if-else construct. So what I'm going to do here is I'm just going to type this code, and I'll walk you through the code in a second. So what I'm going to say here is I'm going to say if this math random is smaller or equal to 0.5, then I'm going to increase the heads variable by 1. If that's not the case, so else, I'm going to increase the tails variable by 1. Oops, by 1. Okay, and then at the end, and bear with me, I'm going to explain this in a second, but in the end, I'm going to output heads. So I'm going to say however many heads and however many tails. All right, So I'm going to save this, and I'm going to go over, reload this page. So here you see we got 6 heads, 4 tails. Reload, 4 heads, 6 tails, 5, 5, and so on. So now we have this idea that we had in the first lecture, or that we saw on the coin tossing web page in an earlier video. We have it implemented in JavaScript. It's quite great. So you can see here, most of the time you get 4, 6, or 5, 5, occasionally a 7, 3, and occasionally a 2, 8. Haven't seen a 1, 9 yet, but that should come up in principle too at one point. In any case, I don't want to bore you by watching me reload this page. So I'm going to go back to the code and explain how this works. So this if-else idea here, that's a condition. So this is the idea of control flow. Some code should be executed if a certain condition is true. Other code should be executed if that condition is not true. The language keywords here in JavaScript to do this are if and else. And it has a fairly simple syntax. So the generic syntax is if, and then in parentheses, you have a condition. And a condition, just like the one that we had up here, that's also a condition in the for loop. So if a certain condition is true, then in these curly brackets, you're going to define what code you want to execute. So this is quite similar, you know, in syntax, right, to the for loop or even to the function. So you have the if keyword, and then in parentheses you have the condition, and then in curly brackets you have the code that should be executed if the condition is true. And that's exactly what we have here, right? If, and then here in parentheses is the condition, and the condition is that this math random returns a value that is smaller or equal to 0.5. So if that condition is true, then here in the curly brackets, we execute this code where we increment the heads variable by 1. Now, if the if is immediately followed by an else, then we can have in curly brackets here the code that needs to be executed if that condition here is not true. Okay, so if that condition is not true, which means if math_random returns a value that is larger than 0.5, then that code down here gets executed. And you can imagine that this comes in really, really handy in many cases. Sometimes you don't need an else statement. You just want to say, well, if this condition is true, then do this, else do nothing. And rather than having basically an empty code here in the curly brackets, you could just remove the else altogether if you only want this code to be executed if the condition is true. But you do have this else statement, which you'll use quite often. There's also an else if, by the way. So you could have an else if, and then some condition, and then some the curly brackets here with the code that would be executed if the condition in here were true, and finally, if none of those were true, the else would get executed. We'll talk about this a little bit later, but if you just have this simple if-else idea that you want to implement, this is how you do it. So quite straightforward, if-else. Now, just one thing that you'll often see that I want to warn you about. You often see things like this. Say, for example, if math random, I don't know, whatever, something smaller than 0.1, then, do something, heads equals 1, or what have you. You'll often see this type of syntax out there in the wild. Don't do this. It is technically correct, and it will be executed. However, I strongly advise you to always use the curly brackets, because if you don't use the curly brackets, you might introduce some very subtle mistakes down the line. And just don't do this. Just always use the curly brackets, even if you sometimes feel it's faster or shorter to write it without the curly brackets. It will really help you avoid mistakes down the line. Okay, so with that in place, we can now write a function that calculates how often we would get 2 tails and 8 heads. What this code does at the moment, right, is it's basically just one implementation or one execution of throwing 10 coins. But now what we have to do is we have to do this many times and observe how often we get exactly this situation here with 8 heads and 2 tails. And then we will really have implemented this idea of trying to figure out how many times you get 2 tails and 8 heads. And we'll do that in the next video. So I'll see you there.